afternoon, rock stars. Let's get to work. So this is homework 3. So hopefully you are doing this before Sunday night, hint hint, in preparation for the homework quiz you have this week. And again, just a quick reminder that homework quiz opened today at 2 o'clock and should go and run through Sunday night. At 11:59, I think is when it actually closes, and you're gonna have 2 total hours to do it. So even if you are doing the Sunday night, hopefully it's not too late. You still have an opportunity to still take the quiz as well. So this one is an actual proof. So this is not unlike the proofs we've been doing in class the last couple days. You kind of have to have a good sense of what to actually do in terms of proof, and what I mean by that is what you actually have to prove. In this case, we're looking at 3 sets of sides, 3 sets of angles. Now, I know a lot of people shy away from this type of proof in class. That's what I've noticed in terms of writing as a flow style. But I'm going to use that style even though it's not what you guys have used, because frankly, I think it just works better. Like, one of the reasons I actually like using that style of proof for these congruencies is because you do have so much to keep track of, and putting that all on a list, I think you're really seeing the deficiency of that style, which is writing as one big list just gets like a huge one big list. So the first thing we're going to do is maybe just go in our diagram, make sure we do have the information we need, because there's no point actually going through this proof if we don't have enough. So we're looking for 3 sets of angles, 3 sets of sides. Well, I do see the angles here as my first set of angles. I can probably do something with these guys to make angle 2. Angle 3 will be here. So let's say I'm covered on the 3 angles, and I'm looking at angle 2 and angle 3 because these parallel lines, and that'll be discussed further, but I think we definitely have enough information to cover 2 and 3. What we're not necessarily sure of is, do we have enough information to cover the side lengths? So if I'm looking at the side lengths, was I given enough? Do I know enough? And if I'm not given enough, well, I can just walk away. So I do have all 3 angles covered, but do I have all 3 side lengths? Well, do I know anything else besides the fact that I want to prove these congruent? Well, I know angles, I got that. I know these parallel lines, I got that. But do I know anything else? I mean, the question I'm really asking myself is that this HA segment and this AR segment, well, can I prove them congruent? I don't think I can, at least not by itself. So we'll switch it over. How about the WA segment and the AT segment? Can I prove those to be congruent? Well, I don't think so. I mean, I know they're part of right triangles, but to solve right triangles, I need at least 2 out of the 3 sides. Well, if I can't prove these congruent and I can't prove anything else congruent, guys, this was a trick question. Can't prove it. You cannot prove congruency. Not enough information. Insufficient information exists. You can't do anything with it. So this was a trick. You cannot prove these congruent under our current rules. In the future, can we? Maybe. If I gave you some other conditions, like maybe if I said like A is a midpoint, maybe I can. But the fact of the matter is, I'm not told those things. Therefore, this is unprovable. Can't do it. So some of you guys aren't going to like that. But part of this learning of geometry and being good at geometry is knowing when you don't have the things you need and not forcing it. So although I have information about all 3 angles, like certainly these are both right, so they're both 90, therefore they're going to be congruent because they have equal measures. And you may even picked out I have alternate interior angles in another set right here at W and T. I can't tell anything about the lines. And if I can't tell anything about the lines, no matter how strongly I feel these should be congruent, I simply cannot prove it. Right? So I'm sorry, trick question. Hope I didn't fool you. Alright, so number 3, and I know it's misnumbered. There is no number 2. I cut number 2 for that problem I had before to kind of sell the fact that it was a trick question. So everything else got kind of misnumbered, and I do apologize. But number 2 is talking about pure algebra. So you're working on the assumption that these 2 triangles are congruent. So our job is twofold. One, we got to make sure we're matching congruent pieces, and the second thing is we have to make sure we can carry out the algebra. So let's match congruent pieces first. I'll try my best to kind of color code this. We certainly have 80 matched with this value. We know that because we have these tick marks, and we can certainly back that up by looking at our congruency statement. We have XZ, so XZ, and XR, or I'm sorry, ZR, excuse me, matching the other triangle. So that seems to match, to be corresponding congruent. So definitely these are going to be equal. So that gives us an immediate equation to solve 20x minus 20. I'm not going to solve it yet. But I want to point out how I'm kind of picking out these values. Another piece of good information, we have this value 200 and this side length on the other triangle, 3z minus 50. Besides the 2 tick marks, which is a good indicator of congruency, we should, again, make sure I'm checking my congruency statement. We have y over to z, and we have z over to q. So those in the right position, they match. We have high confidence that 3z minus 50 will indeed equal 200. The last one is going to be 5y plus 20, 120. And yeah, we can jump to the conclusion that certainly those should be equal as well because the triangles are, but again, I'm going to be a stickler on this. We need to make sure we're checking our congruency statement. We have y up to x, and that needs to match the same values over here, r over to q. R over to q. So those are going to match, and we're going to set up 3 equations here to solve. I'll solve the third one up here because I don't know if I'll have enough room down there. So you have 5y plus 20 equals 120. From here, algebra takes over. Here's where we're just going to put in some good skills. Subtract the 20 from both sides. So 5y equals 100. Divide both sides by 5. Y should be, in this case, 20. Okay, moving over to the z value again, algebra takes over. So we'll add 50 to both sides to get z by itself. So 3z is equal to 250. Divide both sides by 3. Okay, so let's see, 3 goes into 25 8 times, which is 24, left over 1. 3 goes to 10 3 times, which would be 9, left over 1, so I should have 3 repeating. So z should be 83.3 repeating. Hey, look here, here's some more algebra, so let's add 20 to both sides. Hey-oh, okay, so here's 20x, 80 plus 20 is 100. Divide both sides by 20. My pen is cutting out horribly. And x is going to equal 5. So again, using the definition of congruency, using congruency statement to kind of drive your algebra, you have marks, but if you didn't have marks, you still have your congruency statement, knowing again the order matters, and that's something that's been a common theme this whole week, especially in the homework, that the order matters, the order matters, the order matters. So we have x, y, and z, 5, 20, and 83.3 repeating, or 83 to third. This question is going to be much the same. We're just going to look at the congruency statement, look at the actual figure, match pieces up, and then set up equations to solve them. I mean, that's really going to be the game, and really going to be the case no matter how kind of crazy the algebra gets. So if let's say you started that quiz and now you're coming back and you're saying, well, I didn't understand this thing on the quiz, so I'm looking at this kind of tutorial to help me a little bit out. Again, there's 2 ways to match it. Here we don't actually have markings. I mean, we have these. We have the negative 5y plus 5 is equal to 7z plus 1, but I don't even know how helpful that's going to be. But certainly we know by the congruency markings, but also TW and UW, or I'm sorry, UV, being in matching position. So we should have high confidence that 7z plus 1 is equal to negative 5y plus 5. Now this isn't solvable, which is why I said I don't know how useful that fact's going to be, because I have a z and I have a y. 2 variables, 1 equation, that's not going to help. So let's kind of tear apart diagram some more. Let's see if we can find something more useful. I'm looking at TU. So TU, here's TU. That should be matching with the first 2 letters in this side as well. VW. So again, in terms of high confidence, we can definitely say that 30 is going to be equal to 4x minus 2. That's going to be solvable. In fact, that's the last variable I have. I just have xy. I'm sorry, yz in this equation. I just have x. So let's go ahead and solve this guy. Let's let the algebra take the reins. So we'll end up with 32 is equal to 4x. Divide both sides by 4. We'll have x equals 8. Now we're kind of in a pickle, aren't we? I mean, we have the value of x. We have an equation to solve for y, but what do we do with that? Like, how do I make that work? Well, we can probably do this a couple different ways. Well, we can go back to our diagram, and if x is 8, we can replace x with 8 and come up with the value of this side, or you can intuitively realize that should be 30. We need to find the value of y, the value of z, and ultimately what we actually need is a side length. I mean, we can't have variably defined values and solve an equation. But if I notice that this is a right triangle, which is a critical observation you have to make, then we can solve the final side using the Pythagorean theorem. So if I'm looking at 30, I'm looking at 40. Pythagorean theorem demands that if I take 30 squared and I add 40 squared to it, that's going to be equal to whatever value I have here. Let's call it question mark squared. Again, algebraically working this out, 30 squared plus 40 squared, and take the square root of it, the question mark turns out to be 50. So question mark is 50, which means this is 50, and by congruency markings and by congruency statement, this should be 50 as well. So this equation, although great, was actually invalid. We have to set up 2 separate equations where the 7z plus 1 is going to be equal to 50, and the negative 5y plus 5 is equal to 50. And from here we just solve algebraically. Let's subtract the 1's. So 7y equals 49. Divide both sides by 7. Y is going to equal 7. Same over here. Subtract 5 from both sides. Negative 5y is equal to 45. Subtract both, or I'm sorry, divide both sides by negative 5, and y is going to equal negative 9. Okay, so we have our three values. That should somehow change into a z, or into a y. That should be a z. So z is equal to 7, y is equal to negative 9, x is equal to 8. So again, just kind of reviewing the last step. We don't know the value of these TW and UV, but I do know the two legs of a right triangle, 30, 40. That has to be 50 using the Pythagorean theorem. Once I know that's 50, I'll actually disregard my first equation, break it up into two different equations, setting them equal to 50 because that's the side length, and then solving from there. Okay, this is a wonderful question. I like this question a lot. Hint, hint, nudge, nudge. Probably see this question somewhere. Just saying. Okay, so we have a line segment with these endpoints: 9x plus 4, 3y plus 2, and negative 3x plus 6, and 7x minus 8. And I'm asked to find the midpoint. Well, the midpoint, you might be saying to yourself, well, Mr. Collins, how can I do that? I don't know the numbers. I don't know the values of x and y. I said report the coordinates. That just means give me an expression that represents the coordinates. If I can represent the endpoint coordinates variably, I can report the mid-segment, or I'm sorry, the midpoints coordinates variably as well. In fact, the rules don't even change. We're going to start right here with the midpoint formula, where I have the x value of the midpoint, the y value of the midpoint being equal to the average of the x's and the average of the y's. So in terms of how we're going to work this, well, it's no different. They were just numbers. Like if this was just 9 and 3, and negative 3, it'd just be 9 minus 3. Okay, so they're a little bit larger values. Well, who cares? I mean, that's still a solvable thing. That's still x1, that's still x2, and I can still represent that using an average. So my x1 value is going to be 9x minus 4. My x2 value will be negative 3 plus 6, so minus 3x plus 6. And I'll still divide that by 2. Likewise with the y values, just because they're variably defined doesn't mean it's going to change how I average them. The y value simply becomes 3y plus 2 plus 7x minus 8, and that's going to be all over 2. Okay, this is still going to be a coordinate. It's still going to be at the midpoint. Now we're just into the solving steps of it. Okay, so this is, again, we're assessing your algebraic ability. So we're just going to simplify this expression. If I have 9x's and negative 3x's, that's going to give me a net value of 6x's. Negative 4 plus 6 should give me a plus 2, and that's still divided by 2. On the y side, I have 3y's plus 7x's. Oh, and what? That should be a y. So if you're looking at this problem, I do apologize. That should be a y. That's a pure-on typo on my part. That should be a y. So I have 3y's plus 7y's. That's going to give me 10y's. And then 2 minus 8, let's make that a minus 6. Put that all over 2. Again, I apologize. I didn't catch that. But that should be a 7y minus 8. So please change it to 7y minus 8. So 7y's, 3y's, 10y's, negative 8 plus 2 minus 6, still divided by 2. We're not done simplifying because I have all even coefficients and constants up here. I'm dividing by 2. So I can simplify this a little bit further. So 2 goes into 2 one time, it goes into that 3 times. So my final value here should be 3x plus 1 for my x value of my midpoint. And the y value of my midpoint should be 2 goes into that 3 times, 2 goes into 10 5 times. So 5y minus 3. Okay. So that's going to be the values. All right, let's look on to this one. Equally good problem. Definitely equally good problem. We have this two endpoints. One of them is variably defined, one of them is not. And we're asked to report the distance in terms of a and b, and all that means is that your end result will have a and b in it. Like, I mean, we can't get the variables out, we can't replace them with numbers, just gotta deal with it algebraically. So if I'm looking at distance, it's going to be d. Well, we just got to kind of recall the midpoint, or I'm sorry, distance formula. x1 minus x2 divided by, or squared, and then we're going to add that to y1 minus y2 quantity squared. Because the values come from here, so it just becomes a direct replacement. So we'll take the x1 value, which I'll call a, subtract off the x2 value, which is -3, which ends up being a +3. Two negatives make a positive. Y1 value is going to be b. Subtract off the y2 value, which should be 2. Okay. Now the temptation at this point is going to try to claim, for you to try to claim, that this square root will somehow magically cancel these two squares. That is simply not the case. That does not actually happen. Not when you actually have added terms. If this is all a single term, in other words, no addition, linking two separate terms together, then yeah, that rule would apply, but it doesn't apply here. So we actually have to work this out. We actually have to expand this this quadratic. If you left it like this, I mean, this would be totally cool. Like, I would take this as an answer because I've never demanded you take it farther than that. But if you want to take it farther than that, here's how you do it. Underneath the square root, we're just going to actually have to simplify these binomials, these quadratic binomials. In other words, a plus 3 times a plus 3 would yield a squared plus 6a plus 9. And b minus 2 quantity squared would yield b squared minus 4b plus 4. This turns into a game of simplifying. I'm going to keep the square roots. We can't do anything with the a squared. We can't do anything with the b squared. Here I have plus 6a minus 4b. The only thing we can actually affect are the constant numbers, and that's going to give me plus 13. And that's an equally acceptable answer. So whether you take it another extra step or just leave it variably defined, they're both representing the distance between these 2 points. So again, quick reminder, the online quiz opened today at 2 o'clock. It is due Sunday, but by 12:59. That is be submitted. It is a grade. Some people ask me, is this a real grade? Yeah, it's a real grade. It's a real quiz. It does count, so make sure you're taking your time and doing this well. Please don't forget, you're not going to see me have much sympathy for someone who's not going to actually attempt this, or you're going to forget about it. It's a very college thing, like college tests, online tests. They don't care if you finish them or not. It just affects your grade. I want you guys to finish them. Please finish them. Make sure you give yourself enough time to finish them. Like, you guys know, if you can't finish a test to me in the 45 minutes, you shouldn't leave yourself 45 minutes to take this test either. So make sure you're starting this with enough time, and I'll talk about it in class tomorrow. Make sure you're starting this with enough time to actually be able to finish. So until next time, thank you guys very much. And rock stars, I'll see you guys later.